In this video, we are going to learn about Laplace transforms. So, why Laplace transforms requirements? So, if the signal in time domain is complex to uh, derive, then we will transfer to frequency domain. So, here it will simple in terms of our calculations if it is a complex. So, in order to transfer, we using Laplace transforms. So, the signal of time domain will convert into frequency domain by using Laplace transforms. Okay, I hope you got with the definition. Now let us go with the basic formula. So remember, this is important. Here the actual journey starts. So Laplace transform of a function f of t. So what we discuss. So the signal in time domain, right? So means it is a function of t, right? Like f of t defined for t greater than or equals to 0. So where the time should be greater than or equals to 0 means it is not less than 0. Okay, which is equals to the formula, the basic formula, which is defined as Laplace transform of function f of t, which is equals to the function in frequency domain. Okay, function of frequency domain, which is equals to integration the time different from 0 to infinity and f of t e power minus st dt. Okay, so f of t is time domain function, f of s is equals to frequency domain function. Okay, now hence what is meant by this s? Okay, this is exponential, this is a function, this is the integration. Okay, what this term s is means s, which is equals to the sigma plus j omega. Okay, now a simple Laplace which is used for the transforming of time domain to frequency domain, like f of s. Now here basic formula is important. By heart this, like the t different from 0 to infinity because t is greater than or equals to 0. Now f of t function of t e power minus st dt, which gives function in frequency domain. Okay, I hope you got the idea with this basic formula. Now let us solve few problems regarding this. Okay, similarly we are transferring from time domain to frequency domain, right? Then why can't we transfer from frequency domain to time domain? So here, where if we change the things like f of t, which is equals to function f of s e power minus e power st ds, which is equals to f a function in time domain. Okay, this will clear in upcoming section. Don't worry about this now. Now with the basic formula, we are going to define this Laplace transform formulas. These are the problems and these are also formulas for the advanced like questions. Okay, now Laplace of 1, which is equals to 1 by s. Let us prove this thing. So here f of t, which is equals to 1, right? Now this is in terms of f of t, right? So replacing it with a 1. Now integration 0 to infinity 1 into e power minus st dt, which is equals to 1 into something will be the something, right? Now 0 to infinity e power minus st dt. Now integration of e power minus st, which is nothing but e power minus st. Now this thing will comes and down, right? Like minus s, because here we have t, right? E power minus st integration means simply e power minus st. So here again we need to do the integration for this, which will comes under the denominator part, like power minus st by minus s 0 to infinity. Now substitute this thing like upper limit minus lower limit, right? E power minus infinity something power infinity with results 0. Remember this thing, anything it will be if it is an infinity means this will give a 0. Anything with a 0 will give a 1. Okay. Same way here e power minus is 0. 0 and something will be the 0. E power 0 just now we discussed, which is a 1. So 1 by this term is 1 by s, minus into minus plus. Okay. Now 0 plus something will be the something like 1 by s. Let us see Laplace of t. Students, you need to be focused because now things are going into the complex way. Just now we have seen for the Laplace one. Now we are going for the Laplace of t. Later we are going to see the Laplace of n. Again we are coming back from Laplace of n tn to Laplace of t, Laplace of 1. Because here Laplace of n, this is the Laplace of t power 1, this is the Laplace of t power 0. Okay, this is how the things will be. Okay, I'm going in the smooth manner, you need to catch. Okay, now let us see the Laplace of t. Laplace of t equals to 1 by s square. Now Laplace of t. Now f of t here is t, right? Like t into e power minus st dt. Now I think you all people know about integration of u dv formula, which is nothing but uv minus integration of v du. Okay. Now apply the same concept here. Take this term as u and this term as dv. Okay. U equals to t, right? Du equals to dt. Now let us go for the dv. dv equals to e power minus st dt. Now integration on both sides, or taken go the d to this side, means v equals to integration of e power minus st dt, right? Just now we have seen integration of e power minus st dt, which is nothing but e power minus st by minus s. Okay, v equals to e power minus st by minus s. Now apply this thing in the formula, like which is a uv, right? U, where is the u? U is t. T. What is the v? E power minus st by minus s. So this is the term we will get, minus v du. Okay, what is the v du? V du is integration v du. Here I define. So integration v du is nothing but 1 by minus, like minus 1 by s integration e power minus st du, which is simplified as e power minus st by s square. Now apply the limits like 0 to infinity. When we apply the upper limit infinity, we will get the 0. Okay, here we will get the 0. Now when we apply the lower limit, when we apply the lower limit, like t becomes 0, like t into g here in this term, like t tends to 0 means the term all becomes the 0 minus e power 0 by something. Okay, which is nothing but we will get when it's simplification e power 0 by s square, which is nothing but 1 by s square. Go once again. Okay, you will get the clear idea. Okay, go from here like Laplace of 1 to Laplace of t. Later we have going to see Laplace of tn. Okay, this is all the one procedure. Now let us see the Laplace of t power n. Now which is equals to n factorial by s power n plus 1. Okay. Now what is the f of t? Which is the t power n. T power n into e power st dt. Okay. Let's take same thing. T power n, which is equals to u. Du equals to du by dt. Let us define du by dt. Nothing but d by dt of t power n, right? Which is equals to n t power n minus 1, which is equals to du by dt. Transfer t to this side, then which is equals to du equals to n into t power n minus 1 dt. Okay. Then dv equals to e power minus st dt. Simplify this, we will get v equals to e power minus st by minus s. Okay. Same. Now substitute in this, like, which is equals to uv, right? Uv minus v du. Let us define here only. When we substitute, so u equals to t power n, v equals to, I kept minus over here, equals to by s e power minus st dt. Substitute limits like 0 to infinity. Substitute, so you will get this term value equals to 0. Okay, now which is a minus, right? Then y I kept plus means here I defined this thing, vd equals to minus v, where is the v? Here is the v, like e power minus st dt by minus s, like by minus s. What is the du? N, right? n t power n minus 1 and dt. Okay, I hope you got the thing. Now keep here minus into minus plus, right? Here, which is a formula like uv minus integration v du, right? Now here minus, we will get the place. Okay, this term is 0. Laplace of t power n, which is equals to we left over with this term only, right? Like n by s 0 to infinity t power n minus 1 e power minus st dt. Let us assume this term as a. Now a n minus 1, which is equals to, now a n power minus 1, which is equals to n minus 1, right? This is a, replace, this is the a power n, let it be a n minus 1, which is equals to n minus 1 by s. You need to see the difference. Okay, so n minus 1 term is, for the n, here we will get the n. For the n minus 1, here we will get the n minus 1. For the n, here it is n minus 2, right? Similarly, here we will get n minus 2 e power minus st dt, comma, its end up to the a power n minus of n minus 1, right? A power 1, like n will get cancelled, minus into minus plus a power 1. A power 1 is nothing but, like, for the n we will keep the, for the n we will keep n, right? Here we will keep the 1 by s a power 0. Now a power 0, which is equals to the a power 0, which is equals to t power 0. T power 0 is nothing but 1. When the f of t is 1, we will get the 1 by s, right? Same, keep the 1 by s over here. Now 1 by s a power 0 is nothing but 1 by s square. Now let us see. Laplace of t power n, which is equals to an minus 1, an minus 2 up to the a0. Okay, now an, which is nothing but n by s. The terms just we have seen right here, the terms is getting to 0. Okay, n minus 1, n minus 2, n minus 3 by s. A power 0, just we have seen 1 by s. Now this is nothing but n minus 1, minus 2, minus 3. It is a thing of n factorial, right? N factorial by s power n into 1 by s. Now s power n plus s nothing but, sorry, into s means s power n plus 1, right? Similarly, n factorial by s power n plus 1. I hope you got the thing. Just this is a formulas, you need to by heart. I am giving the derivation also. I hope you got the thing on this. Let us see. Laplace of e power at, which is equals to 1 by s minus a. Okay, let us derive this. like f of t here is e power at. So substitute in this place, like 0 to infinity e power at e power minus st dt. So when you observe this, the bases are equal like e, and powers also somewhat equal, like common is t, right? So when bases are equal, we can add the powers, right? Like at minus st, like powers are at minus st. When we take t as common, it is like e power common is t a minus s dt. When we do so, we will get integration of e power a minus st, which is like e power this thing by, here we have t, right? The thing whatever with the t will come in the denominator, right? Like a minus s and 0 to infinity. When we do with the upper limit, like when we go with the infinity, e power infinity 0, e power 0, like for the lower limit e power 0, which is like 1, right? So which is like 1 by a minus s, 0 minus 1 minus 1. So here in the numerator we'll get minus 1 a minus s. So for the minus, let us replace the denominator like 1 by s minus a. So this is how the Laplace of e power at will be. Now let us go with the e power minus at. So here positive, here getting negative, right? If here negative, here it will get positive. That's it. Okay, e power minus at equals to 1 by s plus a. Okay, I hope you got the idea with Laplace of e power at. Let us see Laplace of sin at, which is equals to a by s square plus a square. So let us prove this. Let us take this Laplace of sin at will be the I equals to 0 to infinity e power minus st sin at dt. Okay, change the things like sin at e power minus st dt. Let us take this term as u and e power minus st dt as dv. So I think you all know integration of u dv formula. We are doing in this manner, like integration of u dv will be uv minus integration v du. Okay, this is in this format, right? We are going to derive uv and integration of v du. Now u is, we are taking as sin at, then du by dt, which is equals to cos at. So here a will be come outside, right? Like a into cos at. Take and go this dt to this side, which is like du equals to a cos at dt. Okay, why? Because we need u, not the du, right? We need u and du, not du by dt. So that's why we are transferring the dt to the right side. Okay, now for the dv, what is the dv term? E power st dt. So dv, which is equals to e power minus st dt, when we transfer d to this side, it will become integration, right? So v equals to integration of e power minus st dt. So when we do so, we will get minus e power st by s. Okay, v equals to minus e power st by s. Now for the formula, when we see u dv, like integration of u dv equals to uv minus integration v du. So for the I, which is like, substitute the things. For u is the sin at, v is e power minus st by s. Okay, apply the limits. Now here minus of minus. Okay, substitute v du. V is this thing, du is this. Substitute like this. So here minus into minus, it will get plus. Okay, that's why cancelling. For the 1, let us take this term, right? This term up to here, let us take this is a 1. When we apply the upper limit, it is infinity, right? When we apply the infinity, e power infinity will become 0. and for the lower limit, when we apply the 0, so sin a0 or which is equals to 0 only. So sin 0 which is 0, right? So for this term, with the help of the sin 0, the term again becoming 0. So that's why the term like was first we have taken, right? So this whole thing it will become into the 0. So now we are left over with this term. So now I equals to take a by s to the outside, and we are left over with cos² and e power minus st dt. When you observe, so this thing again we came back to the initial place. See, we something like initial place. Here you can see minus s like sin at e power minus st dt. So here the term is changed, just cos at e power minus st dt. So now let us assume this thing equals to j. When we doing so, like 0 to infinity cos at e power minus st dt, apply same j, like j equals to, when you apply du formula, when you apply u dv formula for this, you will get 1 by s minus a by s, like integration 0 to infinity sin at e power minus st dt. This term again, when you observe carefully, this term which is equals to the I, we have seen, right, which is equals to sin at e power minus st dt. So now j becoming j equals to 1 by s, like 1 by s, a by s and I. So I'm deriving this thing in the below. Now j equals to, we are getting a by s of I, a by s of I. Now I equals to, substitute the whole thing we have taken right here, right, like I equals to a by s, what j become, this whole thing we assumed as j, right? So now j become 1 by s minus a by s into I. So that's the same thing I written here. Now I equals to, simplify this, you will get the formula I equals to a by s square plus a square. Okay, this is how the sin at will be. So now sin at is simply a by s square plus a square. So similarly, you can go do the few things, like Laplace of cos² will gives you s by s square plus a square. For the sin hat, here the only minus will change, like plus to minus will change. For the cos hat, here just simply minus will change, like s by s square minus a square. Okay, so for the how we need to do h things means, here you can see, for the sin hat you can use this formula, like e power at minus e power minus at by 2. For the cos hat you can use this formula, like e power at plus e power minus at by 2. Okay, when you use these formulas in the f of t places of Laplace transforms, so in that the first property is linearity property. Linearity property is nothing but a f1 of t plus b f2 of t. Then we apply the Laplace transform, which is like a f1 of s plus b f2 of s. These are simply a constants. How it is attached to the time function, same way it is attaching to the frequency domain functions. Okay, you can see this Laplace of af of t plus b g of t ch of t, which is equals to a Laplace f of t plus b g of t minus c Laplace of h of t. Okay, a b c constants, f g h are any functions. Okay, this is how the constants will be. Let us see the time shifting property and change of scale property. First shifting property, okay. Laplace f of t is f of s means Laplace e power at f of t, which is nothing but f of s minus a. We have seen Laplace f of e power at, which is nothing but 1 by s minus a, right? Same way, e power, when the e power at term attached to the f of t, we will get like f of s minus a. This is how the function will be. Now same way, Laplace e power minus at f of t is nothing but s plus a. S e power a t Laplace, we will get like s plus a. Now change of scale property. Change of scale property means if anything internally, not here, like Laplace a f of t is different, Laplace f of a t is different, okay. When here the things will be means here you will get like 1 by a f of s by a, okay. When a is attaching here, it will comes into the denominator like 1 by a f of s by a. This is how the scale property will be. I hope you got the idea on this properties. Like if f of t equals to when the time in between 0 less than or equals to t or less than equals to 1, then it will be the 4, or when t greater than the 1, which is equals to the 3, okay. So if it is a 0 to 1, it will be the 4. If it is a greater than the 1, it will be the 3, okay. So apply Laplace of f of t, which is equals to, so first the time in between 0 to 1, the f of t is 4, right? So when 0 to 1, it is a 4. Now 3 to here not given, so up to infinity. So 1 to infinity, it will be the 3. Same thing, f of t e power minus st dt, f of t e power minus st dt. Now simplify this, take and come the 4 outside, which is like e power minus st by minus s 0 to 1 plus 3 e power, same thing, 1 to infinity. So now take and come the minus s to the outside like minus s. Apply the upper limit is 1, so e power minus s, lower limit is 0, something for 0 will be the 1, plus minus 3 by s, e power infinity, which is 0, minus e power 1, like e power minus s. So when you simplify this, you will get this thing, okay. I hope you got the idea how to do such type of questions, okay. Now let us move to the next question. So our next question is Laplace of sin²t. So we have formula for Laplace of at, which is like a by s square plus a square, right? Same way, now sin 3 theta, which is equals to 3 sin theta minus 4 sin³ theta. Sorry, sin 3 theta formula, like 3 sin theta minus 4 sin³ theta, okay. Sin³ theta equals to 1 by 4, 3 sin theta minus sin 3 theta, okay. This is how the formula will be. Now you can see this is similar to this thing, like now because we have only one sin power 1 at, now we are solving for the sin³ 380. So now we are transferred from here to here by using the trigonometry formulas simply, okay. You need to by heart this, like sin³ theta formula, there you can simplify the all those things. Now substitute like sin³ theta will be the 1 by 4, 3 sin 2 theta minus sin 6 theta. Now this is in the type of sin a thetas, right? Apply this formula here, okay. 1 by 4, 3, a is 2, right? 2 by sin like s square plus 2 power 2, which is like 4. Same way this thing. Now when you simplify this, you will get the this solution. Okay, I hope you got the idea on this. Now let us move to the next question. Now our next question is Laplace of sin 2t plus 3. Okay, now let us derive. We have same formula for sin a t. If anything given like sin a t plus b, we are simplifying to sin a t only by using the trigonometric formulas like sin a plus b, which is equals to sin a cos b plus cos a sin b, right? Now sin 2t plus 3, which is like sin 2t cos 3 plus cos 2t sin 3, right? When you simplify this, cos 3 is common. Cos 3 we are taking this side. Now which is like sin 2t 2 by s square plus 2 square, which is like 4. Now sin 3 take here like s by s square plus 4. When you simplify this, you will get this thing. Okay, now let us go for the cos square t. Cos square t, we have formula for cos a t, like which is like s by s square plus a square, right? So anything given like cos square a t, we are changing to the cos a t only by using trigonometry. Same here, like cos 2 theta equals to cos square theta minus 1. Now cos square theta equals to cos 2 theta plus 1 by 2. Okay, like taken go the 1 to this side, which is like cos 2 theta plus 1. Taken go the multiplication of 2. Here it will be the divided 2, like this. Like now cos square t, which is equals to cos 2t by 2 plus 1 by 2. Now apply cos 2t, like cos here cos 2, which is a equals to 2, like s by s square plus 2 square, which is like 4, 1 by 2. Now simplify this thing. Okay, you will get the cos square t. I hope you got the idea on this, the basic formulas. Now let us move further some advanced topics. Let us see the Laplace transforms of derivatives. So nothing but when we have Laplace of d by dt of f of t, then how the Laplace of this derivative is solving, let us see. Now let us go for the first derivative. So when the d by dt in the only first term, like Laplace of f of t, f dash of t, which is equals to s of f of s minus f of 0. This f of 0 in terms of f of t. Okay, so here t is replacing to the 0. Remember this thing. Here f of s is nothing but Laplace transform of f of t. F of 0 is initial value of the function. Now this thing, derivative of time function, is nothing but multiply by s and subtract by the initial value. Okay, multiply by s, subtract by initial value. Now second derivative is nothing but d square by dt square f of t Laplace. For this, let us see the formula. Laplace of f double dash t, which is equals to, sorry, here you will not get the s, which is like s square f of s minus s f of 0 minus f dash of 0. Now Laplace for the third derivative, Laplace of f triple dash of t, which is equals to s cube, see here, s cube, s square, s power 1, s power 0, f of s, f of 0, f dash of 0, f double dash of 0 minus s. Okay, this is how you need to learn, like s cube, s square, s power 0. Okay, f of s here you need to by heart, f of 0, f dash of 0 and f double dash of 0 minus s, all minus. This is how the formula is derived. Okay, now let us go for the general formula, like Laplace of f nth derivative of t, which is equals to s power n, s power minus n, like s power n minus 1, s power n minus 2, s power n minus n. Okay, f of s, like f of 0, f dash of 0, f like n minus 1 and n minus 1th derivative of 0, all minuses. Okay, this is how the general formula of nth derivative. Now let us solve few problems on this. Okay, now our question is, find Laplace of f dash of t. f of t is t square, so if f of t is t square, then find d by dt f of t Laplace. Okay, Laplace of f dash of t, which is equals to, just now we have seen, s f of s minus f of 0. So here Laplace f of t, which is f of s, right? Like f of t, Laplace of f of t is f of s. Then Laplace of t square, which is like f of s, is 2 by s cube, like factorial by sn plus 1. Here n is 2 and 2 plus 1, which is 3. f of s is 2 by s cube. Now f of t is t square, means f of 0 is 0 square, f of 0 is 0. Substitute the things, like Laplace f dash of t, s of 2 by s cube minus 0, like 2 by s square finally, which is like cube and one thing when we cancel out, means here we are left out with the square, right? That's why I written 2 by s square. I hope you got the idea on the first derivative problem. Now let us go for the Laplace of double dash t, f of t equals to t. So if f of t equals to t, then find the Laplace of f double dash t, means here d by dt squares. Okay, Laplace f double dash of t formula is s square s power 0, f of s, f of 0, f dash of 0. Okay, Laplace f of t, which is nothing but the f of s. Now replace f of t with the t, like Laplace of t, then f of s, which is equals to 1 by s square. Now f of t equals to t, right? Then f of 0 is 0, means this term is done. Now let us go for the f dash of 0, like f dash of t d by dt, which is equals to 1, f dash of 0, which is 1. Substitute the all things, like s square, f of s is 1 by s square minus s into 0, and f dash of 0, which is like minus 1, like s square, when we cancel out, we are left over with the 1, right? 1 minus 1, which is equals to 0. This is how the f double dash of t will be. Now let us go for the one property of Laplace transform. When Laplace of t multiplying, like t power n multiplying for the f of t, then it will be the minus 1 power n d power n by dsn, like here f dash of n minus n. This is will be the formula, like Laplace of t power n f of t will be this formula. You need to by heart. Okay, let us solve few problems on this. So when the t power is 1, which is nothing but we are going for the one step of derivation, like Laplace f of t, which is equals to minus 1 power 1 d power 1 by ds1, which is like f of s, t power 1, right? Simply minus d by ds of f of s. So Laplace f of t, first let us go for the f of s. Laplace f of t, which is f of s, which is nothing but s by s square plus a square. Now substitute in this Laplace of t cos²t, which is nothing but minus d by ds of s by s square minus s square plus a square. Apply the formula u by v formula, like u by v dash. Solve this thing, you will get the solution as like this. Now let us go for the t square. T square means d square by dt square, d square by ds square f of s. Okay, t square f of t minus r square d square by ds square f of s. 1 square nothing but the 1, d square by ds square f of s. F of s equals to f of s sin at, right? Nothing but a by s square plus a square. First derivative use, like d by ds of f of s will be the a, because a is a constant, right? Taken come the a here, d by ds 1 by s square plus a square, which is equals to a into minus 2s by s square plus a square. Now d by ds of f of s, when you simplify this, you will get this thing. Now for the second derivative, same thing do. Then you will get this 6a square minus 2a cube by s square plus a square whole power cube. Okay, this is how the things will be. I hope you got the idea on this.
Division by t in Laplace. So f of t, when it is dividing by t, so when we consider it as a Laplace, then what will be, let us see. So for the f of t, we will get f of s. So here 1 by t, right? So 1 by t is considered as integration s to infinity ds. Okay, this term will consider as like this. Like for the f of t, it will be the f of s. Okay, for the by t, it will be like integration s to infinity ds. Okay, this is how the division by t at f of t Laplace will be equals to f of s integration from s to infinity ds. Okay, let us see one problem regarding this. So find Laplace sin t by t. So here the f of t is sin t. Okay, now for the f of t, let us find f of s. Laplace of f of t will be the f of s, right? So sin t, which is like 1 by s square, is 1. Now Laplace of sin by t, which is like add integration s to infinity. This is the f of s, right? D of s. Now this term is nothing but simply tan inverse s. Okay. Now apply the limits s to infinity, like upper limit tan inverse infinity minus tan inverse s. Tan inverse infinity, which is nothing but pi by 2, minus tan inverse s. If we simplify this, we will get cot inverse s. Okay, I hope you got the division by t Laplace. Now next thing is transforms of integrals. So for f of t is there, then for the Laplace here, if it is the 0 to t du means, oh sorry, it is u, f of u du 0 to t, this like means, then what will be means, for the f of u, the Laplace will be the f of s. Okay, for the 0 to t integration and du, this will be the 1 by s. Okay, nothing but f of s by s. Okay, this is also same, but here 1 by s I written, by s here written, anything will be the same. Okay, now let us see the one example regarding this, like Laplace integration 0 to t dt cos hat, cos hat. Okay, uh first it is like f of s by s, right? Then for the cos hat f of s will be the cos hat f of s is like uh, s by s square minus a square, right? So same thing written here. By for this thing is left or right. For this thing we need to write 1 by s. Okay, s will get cancelled. We are left over with 1 by s square plus a square. Again, let us see one more problem. So if we have double integrals means we need to add 1 by s, 1 by s, nothing but 1 by s square. Okay, cos hat, cos hat, Laplace of f of t, Laplace of cos ht, which is nothing but the f of s will be the s by s square plus a square. Okay, for the double integrals, I am adding 1 by s square same. So s and s square will be left over. Now 1 by s of s square plus a square will be the final answer for this. Okay. I hope you got the idea on the transforms of integrals. Now let us move to the next topic. Now let us see the evolution of integrals by Laplace transforms. Nothing but last answer will be the constant in this. Till now we have seen uh, either in terms of t, either in terms of s we will have, right? So these are something a kind of variables. Now the final answer will be the constant, like either it will be the 1, 2, 3. Like let us see the that question, like equivalent integration 0 to infinity t e power minus 3t sin t dt. Compare this thing. So here something is like e power minus st, right? So in terms of s, here it is 3. So now s will be the 3. Okay. Now compare with respect to the like this. This is like integration 0 to infinity t sin t e power minus st dt. Okay. In terms of s, here we have 3. So now what is the f of t? F of t will be the t sin t. Laplace of t sin t will be the this equivalent, right? Now s here is 3. Now t sin t is nothing but sin t, which is like f of s minus d by ds, right? Come to here. Now sin t, for the sin t, f of s will be the 1 by s square plus 1 d by ds. When we simplify this, you will get this. Now put s equals to 3. We find, right, s equals to 3 from the question. Now when we put so, we will get 6 by 100, nothing but you simplify this. This is how the answer will be. Equivalent, nothing but here we are equivalent in the s to the uh, in from the given question. Okay, this is how the things will be in the equivalation of integrals. I hope you got the idea on this. Now let us move to the next topic. Now our topic is like inverse Laplace transforms. So till now we have played Laplace transform because for time domain to uh, frequency domain changing, we are applying the Laplace transform. Now value we need required in the time domain only. People will understand the things in time domain. So from transferring frequency domain, we are calculating and returning back to the time domain. So it is a Laplace transform from here to here position. Then from frequency domain to time domain, we require inverse Laplace transforms, nothing but the reverse process. Okay. uh, Now whatever we seen until now in the Laplace, that thing we are reversing in the inverse Laplace transforms. Okay, first let us uh, go with the formulas we have seen, like f Laplace f of t equals to f of s. Then f of t is nothing but law inverse of f of s. If we convert the law inverse, we will get the f of t. Okay, this is the Laplace transforms formulas. Now this is the transfer, like reversed version of the Laplace transform, nothing but inverse Laplace transform formula. Okay, Laplace f of t will be the f of s. La inverse f of s will be the f of t. Okay, Laplace of 1 will be the 1 by s. Now La inverse of 1 by s will be the 1. Laplace of t power n will be this. If we convert the La inverse for the same, like n factorial by s power n plus 1, which is nothing but t power n. Okay, e power t, which will be the 1 by s minus a. La inverse of 1 by s minus a will be the e power a t. The opposite is the, for the minus, here we will get the place. Same way for the inverse, here the plus means we need to put minus. For the sin at, a by sin square plus a square. If we inverse of this thing, we will get the sin at. Same way for the cos. Okay, now for the hat, like if the things are like uh, 1 by s square minus a square. So s square minus a square, which will qualified under the sin hat. So here the a missing, right? Put the a here and a here, like 1 by a and a, like sin hat by a. Okay. Now let us do one formula thing. La inverse of a by s square minus b square plus a square. Now think carefully. Sorry, this is the whole square. Now think carefully, which is like something. Consider this as the a dash. Let us think like this, like a dash, uh, a by a dash plus let it a dash square. Okay, which is like sin at, right? Put the sin a t in terms of sa dash s minus b, right? Minus b, 1 by s minus b. This is like e power, for the minus it is a plus b t, and multiply this sin a t. This is how the things will be. Okay, now let us go for the properties, like inverse Laplace transform properties. Laplace f of t will be the f of s, means la inverse of f of s will be the f of t. E power a t f of t will be the s minus a. Same way, uh, f of s minus a, which is equals to e power a t f of t. Okay, if it is a minus means here we will get the plus. If here get, if here the plus means here we will get the minus. Okay, uh, like integration 0 to t f of t dt, like integral Laplace transform means, which is f of s by s, right? Same way f of s by s, when we calculate la inverse, we will get the 0 to t f of t dt. T of f of t, like when we multiply by t in Laplace, which is like d by ds of f of s. Okay, nothing but f of s taken. F of s, uh, like d by ds of f of s, when we calculate the line inverse, we will get the uh, t f of t. So here minus missing means we will get the minus. Okay, so division by t thing means like s to infinity f of s d of s, right? Same way, s to infinity, when we have f of s d of s, when we calculate the line inverse, we will get f of t by t. I hope you got the things. Nothing but just reversing. Now let us see few problems on inverse Laplace transforms. Okay. inverse Laplace transform. First thing, find the f of t when f of s equals to s plus 3 by s square plus 2s plus 1 s by 3. This is the a quadratic equation. When you simplify this, you will get s plus 1 into s plus 1, simply s plus 1 whole square. Okay, convert this thing like s plus 3, right? Here s plus 1 we have nothing but s plus 1 plus 2 plus 1 plus 2 will be the 3, same thing, just we are dividing those things. Separate the things, s plus 1 by s plus 1, okay, like this you need to separate. While observe s plus 1, s plus 1 whole square and this thing will get cancelled here, like 1 by s plus 1, 2 by s plus 1 whole square. Apply the law inverse in both sides. When we apply the law inverse Laplace transform, 1 by s plus 1, here we have no squares means simply which is the thing of the e powers exponential power c power minus t. Here this thing is like 1 by s plus 1 whole square, right? When you simplify this, you will get this thing like 2t e power minus t. Okay, now let us go for the second problem. F of s 1 by s minus 2 s minus 3. So here the two things, right, like s minus 2 s minus 3, which is a complicated. So why can't we transfer for s minus 2 and s minus 3, which is easy, right? Something. Okay, let us divide a by s minus 2 plus b by s minus 3. Then what is the a and b? Equal it for the numerator. When we equal it here, cross multiply s minus 3 into a plus b into s minus 2, which is equal to the 1. Put s equals to 2. When we put s equals to 2 here, which becomes 0, which becomes minus 1. Then when we calculate, so you will get the s equals to minus 1. uh, Put s equals to 3. When you put s equals to 3 means this thing will get 0. 3 minus 2, which is like 1. B 1b, which is equals to b, then b equals to 1, right? Simply keep the these things over here like minus 1 by s minus 2, 1 by s minus 3. Apply the law inverse on both sides for this f of s law inverse, which becomes the f of t. Law inverse of minus 1 by 100, okay, which is equals to minus. Calculate this thing, you will get this thing. Okay, I hope you got the idea on Laplace transform inverse problems. Okay, now let us go for the some advanced inverse Laplace. There we need requirement of convolution theorem. Simply now, now we have seen 1 by s minus 2 s minus 3. Suddenly you not get the idea like a by s minus 2 plus b by s minus 3, like s minus 3. No problem, we can do this thing by convolution also. Okay, are you getting? If things getting complex here in the denominator, we can't separate means go with the convolution theorem. This convolution theorem is very easy. First let us learn what is mean by the convolution theorem really is. Like f law inverse of f of s is f of t means law inverse of g of s will be the g of t. Okay, f of s will be the f of t. Okay, g of s will be the g of t. Okay. Consider this is a f of t, unlike f of s, this is a g of s, like this. Okay, when the both are multiplied terms, like law inverse when we calculating, if they are both in the multiplication term like f of s into g of s, then simply calculate for f of u and g of t minus u. Okay, simply it is a f of t and g of t, nothing but here we are replacing with the f of u or f of t minus u, or we are replacing with g of u or g of t minus u. F of u f of t is now changed to f of u, or and g of t will change into g of t minus u. Why? Because this is a convolution theorem. You need to apply the theorem, right? T minus u du integration with 0 to t du. Okay, multiply f of t g of t like this, and integration with g of like 0 to t du. Okay, or you can use here t minus u and here u. Okay, this theorem, when I am saying, you people may think it is so much complicated. Let us solve one problem. You will get a complete picture on this. Okay, how the convolution theorem really is, you will get. Okay, let us take one problem. The problem is, calculate the law inverse 1 by s plus 1 s plus 3. Okay, f of s, let us take this as f of s as 1 by s plus 1, which is equals to e power minus t. Okay, consider this as the f of t, then f of u will be the e power minus u. Okay, when the thing t here change means u. Okay, simply g of s is s 1 by s plus 3, nothing but e power minus 3t, which is equivalent to the g of t. Replace with the u, g of u will be the e power minus 3u, or replace with the t minus u, e power minus 3, like this. Okay, apply the convolution theorem. Law inverse, which is like the f of s, like f of s into g of s, right? Apply the law inverse. Integration 0 to t du f of t f of u g of t minus u, f of u e power minus u uh, into minus 3 t minus u du. Simplify this, like expand this thing, which is like minus 3t minus into minus plus 3u. So e power 3u minus u will be the 2u. The integration is for the u only, right? Then why the terms t in this? So now t is the constant terms, right? Put like put as a prefix in before the integration. Okay, like e power minus 3t. Do this thing, you will get the e power 2u, right? E power 2u by 2 by 2 0 to t. When you do so like this, you will get. Okay, simplify this thing, convolution theorem.